From my personal experience, I find doing proof of concept, aka POC, to be a great way that can help discovering potential non-obvious technical blockers. What's up, builders? Welcome back. Today I want to share 5 engineering principles that I learned in the past few years as a software engineer at AWS. Some of these are based on my personal experiences, while the others were learned the hard way by working alongside other senior software engineers. In this channel, I cover various technical topics, including engineering principles, software technologies, and tutorials, such as how to use certain AWS features. So it won't be your typical gadget review videos, even though I might do that occasionally. If you would like to see more, please give this video a thumbs up, click the red subscribe button, and leave a comment below. Let's explore this expansive technology wonderland together, shall we? First, roll the intro. As you gradually progress through your career, it's inevitable that you'll be given vague problems to solve. The most important thing you can do in this stage is to define the problem. What exactly do you plan to solve? Sometimes on the first look, the problem you're given might seem clearly defined, but once you start pondering on it for a while, you'll realize that it's actually not. One good indicator of whether a problem is well defined is by looking at what is considered out of scope. I personally think the exercise of scoping down is one of the best tools at your disposal to help you figure out what exactly is the problem you're trying to solve. When given certain requirements, challenge them. Ask around to verify why they need to exist. It might well be that sometimes what you're asked to do should not even be done. For example, assuming you're tasked with designing a database system for storing customer data, you should ask questions like these. What will be the access pattern? Does the new API need to support looking up one customer along with his or her data? Or would there be a need to query the database to find customers who meet a specific set of criteria? How long should the data be kept? Is it forever? Probably shouldn't be. Then does it imply that we need to have a time to live attribute per customer? Maybe. All these are good examples of questions that you can ask to help you scoping down the problem. Once you figure out the problem to solve, it's time to start the design. This usually includes what's the preferred option? What can be the alternatives? Their pros and cons? How about the cost of development, such as how fast you can iterate? The cost of maintenance, such as how much time will be needed to keep the dependencies up to date. For example, the Rust language has a standard package manager, Cargo, while the C language does not have such a tool. From my personal experience, I find doing proof of concept, aka POC, to be a great way that can help discovering potential non-obvious technical blockers. In addition, think about how you can divide the actual implementation up into several phases so that you can deliver incrementally. This will also help you prevent accidentally rushing through any kind of one-way door during implementation. For example, let's say your design aims to implement a key-value database. In phase 1, the goal might be to implement the minimum rewrite operations, whereas in phase 2, you'll implement encryption at rest. What are some of the other engineering principles or guidance you can think of? Comment below to share with everyone. Alright? Let's move on. A related tip regarding planning for the implementation is to always leave buffers for the unexpected events. What I usually recommend is first try to break a goal down into smaller tasks. Then, for each task, especially those that appear to be uncertain, times your original estimate by 1.5 or 2 just to be safe. If you truly have no idea how much time is needed to do something, be honest. Just estimate the amount of time needed to do the research, and then make it clear that additional time will be required afterward to finish the actual work. When facing unknowns or options that seems equally good, choose to do as little as possible, as simple as possible. When I was a junior engineer, I learned this lesson the hard way multiple times. I often chose to go above and beyond by implementing for the most involved and comprehensive use case I could imagine. Luckily, the senior engineers that I worked with at the time rejected my code, and turned out they were right. Simple code is not just easier to write, they're also easier to test and will contain less bugs down the road. Another principle that's somewhat related to the previous one is, don't expose too many configurations to customers initially. Instead, start with some sane defaults that customers cannot change and gradually open up the door for more flexibilities down the road when their actual customer asks. The main reason behind this is because before you actually have a large user base and concrete customer asks, all these flexibilities that you thought are necessary can actually backfire and lead to, at best, more cognitive load, and at worst, a confusing product or service that no one wants to use. I post a new video pretty much weekly, so if you like the content you just saw, don't forget to like the video, leave a comment below, subscribe to my channel, and share it with your friends. Have a good one, builders. 我们下次见。